So our next theorem is actually something that we've already talked about, but we do need to prove it in order to use it as a reason in our proofs, and that's the vertical angles congruence theorem. So you want to write this down in your notebook. Here's the setup of the proof, and remember we have our statements and reasons. So take a moment, write that down. Okay, so remember our statement. Our first statement's always matching the given of the proof, so angle 5 and angle 7 are vertical angles. Now, as we've discussed, we knew that angle 5 and angle 7 were congruent, but that's not something that is known. The definition of vertical angles is that they are non-adjacent angles formed by intersecting lines. The definition says nothing of the fact that they're being congruent. That really has to do with the vertical angle congruence theorem. So we need to prove this. Once we prove it, we know it's true for all cases, and then we could put it into our reasons bank. So the fact that they're vertical angles in the given does not lead us to additional information. You really need to look at the sketch now and see what's happening. They give us angle 5, angle 6, and angle 7. What we do know is that we can see that 5 and 6 are a linear pair, and 6 and 7 are a linear pair. So what that means is, since they're a linear pair, we see that in the picture, we know that angle 5 and angle 6 are supplementary, and angle 7 and angle 6 are supplementary. And the reason for that is the linear pair postulate. Knowing that if two angles are a linear pair, they are adjacent and supplementary. That's a known fact, and we've talked about that. So the reason here is that it's a linear pair postulate. Now, do you need to state first they're a linear pair? Technically, I would say yes, and the book does do that. You could first say in between 1 and 2 that angle 5 and angle 6 are a linear pair, and angle 6 and angle 7 are a linear pair, and that would be by the definition of a linear pair. But we actually, for what we do in our proofs, we skip that step and we go right into saying they're supplementary by the linear pair postulate. So what does it mean for angles to be supplementary? What it means to be supplementary is that they add up to 180 degrees. So using our previous statement, which is that the fact that they're supplementary, we come up with our next statement is that they add up to 180 degrees by the definition of supplementary angles. And when we add angles, we are adding their measures together. So the measure of angle 5 plus the measure of angle 6 equals 180. Measure of angle 7 plus the measure of angle 6 is equal to 180. Now you will see that each of these equations is equal to 180 degrees. So when we see that repetition, or that equality I should actually say, we have two equations that are equal to the same value, we could then substitute and set them equal to each other. So our next step is going to be substitution, and we're going to say that the measure of angle 5 plus the measure of angle 6 equals the measure of angle 7 plus the measure of angle 6. And that's through substitution. We basically substituted out. We crossed out, if we want to look at it with a pen here, it's like we taken this expression right here, whoa, I don't know why I just did that, sorry, and replacing it here for that 180 degrees. Okay, that is substitution. Now, you will see that you have angle 6 on each side of your equation. So we could use our subtraction property of equality and then subtract angle 6 from each side and end up with the measure of angle 5 equals the measure of angle 7. Okay, that's just simple subtraction. You're subtracting the same degree measure from each side. Keeping the end goal in mind, which is that you want angle 5 congruent to angle 7, you actually have it already, right? If you know that the two angles have equal measures, you know that then the angles are congruent. So our proof statement, which is our last step, is that angle 5 is congruent to angle 7, and we've already seen this reason before. That's the definition of equal angles.